Like to do a few more examples on the elimination method for systems of equations when you have three variables and three equations. The video did not work well yesterday, so I just wanted to give a few more examples. So for this first one, let's work the problem 4x plus 2y plus 3z equals 1. And 2x minus 3y plus 5z equals negative 14. And 6x minus y plus 4z equals negative 1. So here's our original problem, and I like to separate that from the rest of it. So the first thing you need to decide is which variable you would like to eliminate. You can pick the x, the y, or the z. So what you want to do is you want to take this equation from three variables and three equations into two equations with only two variables. So let's say we would like to eliminate the x's. So I just like to put a note about which one I'm eliminating, so that way I can just keep that in my mind. So first of all, this is equation 1. This is my second equation. This is my third. So if I want to eliminate my x's, I'm going to rewrite them twice. So I picked two that I want to eliminate to start with. So first I'm going to use equation number 1 and equation number 2. So that is 4x plus 2y plus 3z equals 1. And 2x minus 3y plus 5z equals negative 14. And it's very important to make sure that when you're copying problems that you copy it exactly the way it's written, or else you will make a mistake somewhere and get really confused. So double check if you miss something and make sure that everything is copied correctly. So if I'm eliminating the x, I have a 4x on the top equation. Well, to make the x's disappear, I can change the bottom equation to have a negative 4x, because a positive 4x and a negative 4x add together to make 0. So to get the bottom equation to change to a negative 4x, I would multiply that entire row by a negative 2. So I'm not changing the first equation this time, so I'm going to copy it just like it says. And I'm going to distribute a negative 2 to all four of the terms in the second row. So that would become a negative 4x. That would become a positive 6y. That would be a negative 10z equals a positive 28. And I'll draw my line there. And the x's do, in fact, cancel out. And then I will combine my y's and my z's and my constant terms over here on the end. So when I combine my y's, I get 8y. Positive 3z minus 10z is negative 7z. And 1 plus 28 is 29. So now I am down to one equation that has two variables instead of three. So I want to do the same thing again. And back to the original problem, I picked equation 1 and 2 for the first time. Now this time I'm going to do equation 2 and 3. So I'm going to recopy those. Nope, negative 14. And the third one is 6x minus y plus 4z equals negative 1. And the same variable that you eliminated with the first two sets of equations, you need to do the same thing with the second set. So since we eliminated x the first go around, I'm trying to eliminate x again. So if I notice the bottom has a 6x, and so to get the top to cancel out with it, I need a negative 6x. And I can get a negative 6x by multiplying the top row by a negative 3. So remember, whatever you do, you got to do it to the whole equation that it's in. So I'm going to multiply the whole top equation by negative 3. That would get me a negative 6x. That would get me a positive 9y. Negative 3 times 5z is a negative 15z. And negative 3 times a negative 14 is a positive 42. And I will just keep the second equation just like it is. Draw my line. My x's eliminate. 9y minus y is 8y. Negative 15z plus 4z is negative 11z. And 42 minus 1 is 41. So now down here at the bottom, I now have two equations that have the same variables. Since we eliminated all the x's, I have a y and a z. So I'm going to come over here and stack those on top of each other. Again, make sure you're copying correctly. And I want to use the elimination method on these as well to eliminate one of my variables. If you notice that 8y's have the same coefficient in front, so to get one of them to cancel out, I need to multiply one row by -1 so that they will have opposite signs and cancel out. So it doesn't matter which one you choose to do that with. I'm just going to go ahead and do it with the first one. So if I distribute a -1 times the entire first equation, I will now have a negative 8y plus 7z equals a negative 29. And then I will bring down my second equation, and I am not changing that one. So now my y's cancel out, and 7z minus 11z is negative 4z. And negative 29, this is z by the way, negative 29 plus 41 is a positive 12. And then I divide both sides by -4. And z equals -3. So I have one variable that I know exactly what it equals now. It equals -3 for z. So to get a y, I just plug that back into one of the equations that had a y and a z in it. So this one right here is fine to do it with. So I'm going to say 8y minus 7 times -3 equals 29. So that's 8y plus 21 equals 29. And I subtract 21 on each side. 8y equals 8. Divide both sides by 8, so y equals 1. And then I go back to one of the very original problems. Doesn't matter which one. I'm just going to use the top one just because it's on top. And so I'm looking for x now because I know y and z. So 4x plus 2 times y. Now I know y is 1, so I substitute that in. Plus 5 times -3. -3 is my z, equals 1. And then I simplify that. That's going to be 4x plus 2 minus 15 equals 1. 2 minus 15 is -13. I'm sorry. I miscopied my problem. So this should be a 3 right here. And this is -9. See, that's why copying correctly is very important. So that would make -7. And then I add 7 to both sides. So 4x equals 8. I divide both sides by 4. And x equals 2. So now I know all three solutions. And we're going to write the answer in an ordered triple. So just like an ordered pair has an x and a y coordinate, an ordered triple has an x coordinate, a y coordinate, and a z coordinate. So our answer for this one will be in that order. So x is 2, our y is 1, and our z value is -3. And that is our solution. And we could check it by plugging those coordinates in for x, y, and z into all three original problems. And if they all come out to be true statements, then our solution is correct. So hopefully this was just one more example that you can see all the way through of solving an equation, a system of equations with 3 variables and 3 equations. Have a good day.